Hello everyone, my name is Ajay. In this video, I'm going to explain you about the problem called array manipulation. Uh, so it is actually a question from hackerrank.com. So if you want the complete question, I'll post that question in the description of this video so that you can get it from there. So coming to the question, so you're actually given n equal to 5 and array of array queries. So you are given n equal to 5 and multiple queries, so you have to perform those queries on an array of length n, and finally you have to result a value. So what value I will be explaining you exactly. So here you can see I'm having three queries. I'm given three queries and I'm having n equal to 5, so I have to create an array of length n, which is 5, with all the values as 0 initially. Okay, so here if you can see, I named it as a bk. So for each query, first value is a, the second value is b, and the third value is k. So a and b here are actually the indices and k is the value. So I'll just say it as points instead of indices to just make it simple. So I will name each and every index as points, like 1, 2, 3, 4 and 5. So the index is actually 0, 1, 2, 3, 4 for this array. So the problem is you have to perform each and every query on this array. So these are the indices and this is the index. So if you see, in the first query I'm having a and b are the indices. I have to add 100 from point A to B, so which is 1 to 2. So let me perform query 1. So after performing query 1 to this array, I have to add 100 from point A to B, which is 1 to 2. So 1 to 2 is nothing but from here to here. So that will become 0 plus 100 is 100, 0 plus 100 is 100, and all others will be 0. So this is after executing query 1. So let me execute query 2 now. So query 2, here I am having A as 2 and B as 5, and I have to add 100 from 2 to 5. So from 2 to 5 means from here to here. So that will give me 100, and it is from here to here that I have to add 100. So it's already 100, so if I add one more 100, it will become 200, and all others will be 100, 100 and 100. So if I execute query 3, so I have to add 100 from 3 to 4, which is nothing but from here to here. Okay, so after adding 100 from 3 to 4, so it's already 100, so I have to add 100 from 3 to 4. So I'll be adding one more 100, so it will become 200. Here it will be 200, and this will be 100. Okay, so after performing all these three queries to this array, I got the values as like this. I got the values here. After performing all the three queries, the values were like this. So after I perform all the three queries, I have to actually find the maximum value from that resulted array. So here if you can see, the maximum value is 200. So I have to return that value after performing all these three queries. So that is the problem, guys. So let's see how we can actually solve this one. So there are actually multiple ways for solving this. So I'll be explaining you a brute force solution as well as an efficient solution. So first, coming to a brute force solution. So if you can see, it is a straightforward solution. You can simply iterate each and every query, and again in the iteration of each iteration of these queries, you can perform an inner for loop, and you can iterate all the elements of the array, and you can add 100 from point A to B, and finally you can get the maximum value of the resulted array. That way you can do the brute force. So I'll also explain you how you can do. I'll code and show you the brute force solution as well. So if you can see, I've written the function prototype here. So it's the return type is long, and I named it as solution. It takes two input parameters int and array of queries. So it is a multi-dimensional array which is cube. Okay. So first I wanted to create a array. First I wanted to create an array of length n. So for that I will use long and I will name it as array equal to new long of length n. Okay. Once I create an array with length n, now I need another variable to hold the maximum value. So I will declare another variable called max. So actually I'm coding this in C#. So the data types are in C# are like this. So if you are coding in any other programming language, maybe you use the data types accordingly. So this is in C#, so I'm using data types as per C#. Also, if the code is not clear here, don't worry, I'll post the link of this code in the description of this video, so you'll get the complete code. Okay, so long max, now it will become, I'm just assigning the minimum value of long to this. It's a predefined one. So once I get the variables, I'll start looping the queries. Okay, queries is nothing but cube. It is an array of arrays. So for each array, I'll be having again array. So I will start looping it. I will just for each var item in cube. So item is nothing but one query. So each item will be having all these three values. So each item is nothing but it's array. Okay. So I'll be iterating the queries. So for each item, so initially I want to have these values A, B and K for each item. So for each item I'll be having three values. So I'll get those three values and store it in the local variables A, B, K. So for that I'll declare int A equal to item of 0 and int B equal to item of 1 and int K equal to item of 2. Okay, and now if you can see the indices are actually the indices which are points are starting from 1, 2, 3, 4, 5, so on. But the array indexes actually start from 0 to n, 0 to n minus 1. So if you can see, the indexes are actually 0, 1, 2, 3, 4, 5. So that means if a equal to 1, that is nothing but index 0. If b equal to 3, that is nothing but index 2. So which is minus 1 of 3, which is minus 1 of 1. So for that I will just use minus 1 for a and b. Okay, that way I'll get the exact index of that point. Okay. So once I get the values in the local variables, now I'll start iterating this array AR, and I will add 100 to the points from A to B. Okay, so for that I will use one more for loop for int I starts from point A and ends at point B. Okay, so I will start from point A and I less than or equal to B I plus plus. Okay, so now I will add k value from points A to B. Okay, so for that I will use AR of 5 is equal to AR of 5 plus k. Okay, and also in each iteration I want to keep track of maximum value. So for that I will check if AR of 5 is greater than max, then I will just update the max value to AR of 5. That way I will get the maximum value by end of complete iteration. I will close this for loop and I will close it for each, and I will finally return max. Okay, so that's it, friends. So here in the inner for loop I am actually adding k value to all the elements from point A to B. and finally, and also I'm keeping track of maximum value, and finally I'm returning that maximum value. That way, by end of the complete iteration, I will get the maximum value and I will return that value. So coming to the time complexity of this solution. So here if you can see, I'm iterating the query. Here I'm in the outer for loop, I'm iterating the queries. So let's say the length of queries is n. Okay, the length of queries is n. So here we are having 3 queries. The length is 3, which is nothing but I'm naming it as n. And let's say the array length as n. So here if you can see, in the outer for loop I am iterating all the queries, and in the inner for loop again I am iterating n items in worst case. So that is nothing but m into n. So total time complexity is equal to big O of m into n. Okay. So as I'm having a inner for loop, it is into. Okay. So this is the brute force solution, friends. So if you run this solution in the hackerrank.com, it will run quite a few test cases, but it will fail for few test cases as they are expecting it to be done more efficiently. So let's see how we can actually do more efficiently. So for making it, so the efficient solution time complexity would be actually big O of m plus n. So this is the efficient solution for this problem. So I will explain you how you can actually approach it. So let's see how we can solve this in the time complexity big O of m plus n instead of big O of m into n, which is way more than m plus n. Okay. So solution 2, which is the efficient one. So for making this more efficient, you can use algorithm called prefix sum array. So it is nothing but prefix sum array. So by using this algorithm, you can actually make this problem little efficient. So I will be showing you how. So before that, I want to explain you a little bit about prefix sum array. So prefix sum array is nothing but, for example, if I'm having an array of elements like 1, 2, 3, 4, 5. So the prefix sum array of this would be the current element plus the previous element. Okay. So the current element is 1 and the previous element is nothing, so it will be 1. So the current element here is 2 and the previous element is 1. So the sum of the current element and the previous element. So 2 plus 1, that is 3. Now 3 plus 3, that will become 6. 4 plus 6, 10. 5 plus 10, 15. So it is the sum of the current element plus previous element. Okay. So here for the first index we don't have any previous element, so it will be same. Then after you will be having the sum of the current element plus previous element, like this. Okay. So this is the prefix sum array. So by using this, you can actually solve this thing efficiently. So I'll be showing you how you can solve that one. Okay, I'm erasing this. So first I want to write the array here 0, 0, 0, 0, 0. So the length is actually 5, but I have written the array of length 6. I'll let you know why I added one more element additional here. So just bear with me. Okay. So I'm having the array with length 6 now, though I'm having n equal to 5. So I'll be explaining why I kept 6 in a while. So I got an array of length 6. Now what I have to do is just if you take the first query, so just make the point 1. So I'm writing the points here. Point 1 to 100. So add 100 to the point 1, which will become 100 here. Okay. So I'm just adding 100 at point A. Okay. So this is the first query. Okay. And then after I'll if you perform a prefix sum array for this array, let's see how it will look. So I'll be performing a prefix sum array. So the first element will be 100, and then after the second element will be 100, and third will be 100, fourth will be 100, fifth will be 100, sixth will be 100. So after performing the prefix sum algorithm, I got the resulted array as hundreds in all the places. But as per query 1, I actually need to add value 100 from point 1 to 2, which is from year to year. So here you can see, but after applying the prefix sum, I was able to add for all the other points also with 100. So to avoid that one, what I will do is, when I'm at point A, I added k value as 100. At the same time, I will also add minus k at b plus 1. At b plus 1 is 3 here. So if I add minus 100 here, if I add minus k here, I will get minus 100. Okay. So first you have to just make the point A to k. You have to add point A with k, and then point b plus 1 to minus k. So you will get this array. And now if you apply the prefix sum algorithm, you will get the query as, so first will be 100, and the second element would be 0 plus 100, that will be 100. And the third element will be minus 100 plus 100, that will give me 0. The fourth one, 0 plus 0, 0, 0 plus 0, 0, 0 plus 0, 0. Okay. So here if you can see, this query is matching this query here. So after applying the prefix sum array for this array, I'm getting the array as like this, which is equal to this array here. So they both are matching. That means by applying prefix sum, I'm getting the same array. So let me do for query 2. So instead of just performing one query, I will perform all the 3 queries to this array, and I will do the prefix sum array, and then let's see how it will look. So I'll erase this for now. So at as per query 1, I added 100 at point A, and I separated 100 at point B plus 1. So which is 100 and minus 100. Now if you go to query 2, I have to add 100 at point 2, and I have to separate 100 at point B plus 1. So B plus 1 is nothing but 6. So that will be 100, and at point B I'll be adding 100, and 3 is minus 100, and at point all will be 0, 0. At point B plus 1, which is 5 plus 1, 6, I'll be adding minus 100. Okay. So this is after query 2. So here I'm just adding 100 at point A and subtracting 100 at point B plus 1. So after now if I perform query 3, so query 3, I have to add 100 at point 3, and I have to subtract 100 at point 4 plus 1, which is 5. So that will give me 100, 100. So at point 3, I have to add 100. So it's already minus 100. So after adding 100, it will become 0. And this all will be 0. Okay. At point 5, which is 4 plus 1, B plus 1, I have to separate 100. So that will be minus 100 here. And finally, I am having minus 100 as per previous array. Okay. So now I performed 3 queries here, and I got the resulted output, resulted array like this. Okay. So once I just add the values at point A and separate the values at point B plus 1, I got the final array like this. Now I will apply the prefix sum array algorithm. Okay, let's apply it. So the prefix sum algorithm will be, the first element will be 100, and the second element will be 100 plus 100, that will be 200, and the third element will be 0 plus 200, that will be 200, fourth will be 0 plus 200, that will be 200, fifth will be minus 100 plus 200, that will be 100. The last will be minus 100 plus 100, that will be 0. Okay. So if you see, this array, this output array and this output array are similar. 100, 200, 200, 200 and 100. The last one, as I said, I added this element only to avoid this scenario, like when b is 5, when b is equal to the length of array, then I have to subtract k value at b plus 1. So for that reason I just added it as a temporary thing. So if you can see, after performing the prefix sum array, we got the same output like this that we did in the brute force solution. So once we get this prefix sum array, you can get the maximum value, which is 200, and you can return that one. Okay. So let me actually code this and let me explain you how exactly this works. Okay. So this is the efficient solution. So the time complexity is big of m plus n. I will explain that. I will keep everything same. Okay. So now I iterated the queries and I got a, b, k values. I have to just set a value to k and b plus 1 value to minus k. So for that I will do array of a value to array of a plus k. Okay, and array of b value b plus 1 is equal to array of b plus 1 minus k. Okay, as I said, at point A I am adding k value and at point b plus 1 I am subtracting k value. So this is the thing. I'll close the for each loop, and now I will apply the so once I'm done with this, I will apply the prefix sum algorithm to the resulted array. So for that I will use a for loop for int I equal to 0, I less than n, I less than n plus 1. Why? Because I took the array of length 6 here, I plus plus. Okay, and I'll close the for loop. I'll close the for loop here. Okay, so now I'll apply the prefix sum, which is nothing but, so if I equal to 0, so if it is the first element, then I am doing nothing. So for that reason I will skip when I equal to 0. So if I not equal to 0, I'll perform the operation which is nothing but array of I equal to array of 5 plus array of 5 minus 1. So current element plus previous element when I is not equal to 0. That way I can perform prefix sum algorithm to the array. Okay, and also in each iteration I will also keep track of maximum value. So for that I will check if array of ai is greater than max, then I will update the max value to array of ai. Okay, and finally I'll close the for loop here, and finally I will return max value. Okay, so that's it friend, this is simple. So in this for loop I'm just making the point A and point B plus 1 to plus k and minus k, and once I did this thing, I'm just applying the prefix sum array for the resulted array in this for loop, and also I'm keeping track of maximum value, and finally I'm returning the maximum value. So that's the efficient solution friends. So let's see the time complexity of this. So here if you can see, this runs for m times, and and this runs for n times. So that is nothing but m plus n. Time complexity is big of m plus n for the efficient solution. So for the brute force solution, we are actually looping again we are actually keeping an inner for loop inside this loop. So that is the reason it is m into n. So here this for loop and this for loop are separate, so that is the reason it is m plus n. So the time complexity of this solution is much less than this thing, the brute force one. So that is about this array manipulation problem, friends. So if you have any questions, please post them in the comment section of this video. And if this code is not clear, don't worry, I'll post the link of this code in the description of this video. That'll be all. Thanks a lot for watching my video. Thank you.